13.2 Absolute value functions and transformations. Here is some absolute value information that you should know before we get started. The standard form of an absolute value function is y equals a absolute value x minus h, close the absolute value, plus k. Now this is just the standard form. I'm going to give you some examples of equations that are in the standard form of an absolute value function. I put here some examples where, okay, the y equals 3, so our a is 3, and then our h is negative 3, and our k is positive 5. So you can see they're all in standard form. If you don't see a number here in front of the absolute value, then that would mean that's a 1, even though it's not showing a 1. There is a 1 here. The h would be the negative h would be a positive 2, and the positive k would be a plus 4 for this example. For our next example, again, there's no number here for a, so that would mean that that's a 1. There, for the negative h, it would be a positive 7. And for the positive k, there's nothing here, so this is actually a plus 0. So let me show you what that looks like. So if I were to fill in the gaps here, the a is a 1, the negative h would be a positive 7, and the k, since there was nothing at the end of the absolute value, would be a plus 0. So even though you don't see numbers, there are actually numbers here. Okay, I'm going to fill in the gaps for our next one. Since you don't see a number here, you don't see a number in the h position, and you don't see anything in the k position, I'm going to fill that out for you. Okay, you can see in the last example, y equals the absolute value of x. But remember, we do have a number here in the front, which would be a 1, even though it's not showing it. And there is a number for h, for the value of h here. So that would be a plus 0, because x plus nothing is still x by itself. And then here at the end, I would have to add a k, so I have to add 0, because the absolute value plus nothing is still the absolute value of x. So you can see that these gaps get filled in. Now that's going to become important, because I'm going to talk to you next about how you get a point from the graph. Just by looking at these numbers, you will be able to graph the graph very quickly. The first word that I would like to go over in the vocabulary section would be vertex. This is a point where two or more rays or the arms of an angle meet. So you can see here that's a ray, and this is another ray, and they're going to meet at this point. This point is called a vertex. Now, that point is going to be very important for you graphing your absolute values. When you have an equation that has an absolute value symbol, these two in it, you will have a V-shaped graph. So this will be what happens to your absolute value. So you can see that your absolute values will become that V shape when you graph it. It's not going to look like a line. This time your graph from absolute value goes into a V shape. I'll show you how we're going to get this vertex and where you're going to go ahead and move this V shape. So I'm going to show you how you can move this V shape up and down on your graph and where your points go on the next slide. Okay, I'm going to show you an example. This is the standard form again, y equals a, absolute value of x minus h, absolute value close, plus k. Now this h and this k become your vertex. So you can see here that this in the problem was a negative h, but when I put it in the vertex as a point, it's a positive h. You notice that the negative is not there anymore. For the k, it was a positive k, and it's still a positive k. So this tells me that whatever number I have in this position, it needs to change signs. So I'm going to always change this sign, and that'll become my h. And I'm always going to keep this sign the same. So if it's a negative, I'm going to keep it a negative. If it's a positive, I'm going to keep it a positive. So that'll be my k. So let's go look at our problem here. According to this, I'm supposed to change this number. So I'm going to find the vertex for this example. Y equals absolute value of x minus 3, absolute value plus 4. Now if you notice, I didn't put an a here. I'll deal with that in a bit. Okay, so you can notice here that this was a negative 3, but once after I change the sign, it's going to become a positive 3. And then I keep the k, which is a positive 4, so I'm going to keep it a positive 4. And this becomes my vertex. So that's the very first point that I'm going to graph. And you can see that it's very easy. Just by looking at the equation, you automatically can know what the vertex is by changing the first sign and keeping the second sign. Okay, I'm doing one more example for you. So you can see here that even though I have a number before the absolute value, that's not what I'm looking at to find my vertex. I'm going to look in here in the absolute value to see if I have a number and another number on the outside of the absolute value. So I need to change my first sign, which will become a negative. The first sign will become a negative 7, and the second sign I need to keep it. So I change my first sign from a positive to a negative, and the second one I need to keep my sign. So this is going to be still a negative 15. So my vertex is at negative 7, comma, negative 15. I'm going to do one more example. This equation has the a, and you can see that there's no h and there's no k. So I'm going to rewrite this equation so that you can see there's actually a number here after the x and there's a number outside for the h and for the k. Okay, I have made the equation for this absolute value, y equals 7, absolute value of x. I have changed it so that it looks slightly different. You can see now that there actually is a number here. It's just a plus 0. And there is a number outside of the absolute value, which is also a plus 0. So the vertex for this problem will be 0, comma 0. And I'll talk about that right now. Okay, again, a reminder. I'm supposed to change the h, the sign there. And if you look here, even if I change this to a negative, zeros are not negative. Zeros are neutral. They do not have a positive or a negative. So it's just 0. Also for this one here, I need to keep the sign, but either way, even if I keep the positive, positive 0, 0, still 0. So my vertex is 0, comma 0. Okay, I'm going to talk about part B here, and this is on page 591 of your textbook. So let's talk about what we just learned about our vertex. So if we look here, we have a negative 4, and I'm supposed to be changing that. So my vertex is going to be positive 4, comma. And now if you look at this one, I'm supposed to be keeping that. So I'll just remind you there. So we're supposed to change this sign, and we're supposed to keep the second sign. So we're going to keep a plus 2, so that's positive 2. So my vertex is at 4, comma 2. Now you can see that my original equation is the parent function. This is what we call a parent function. So a parent function for an absolute value would be y equals the absolute value of, let me fix that there, the absolute value of x. So this would be my parent function. Now my parent function is this equation here, the first equation, because it's at 0, 0, first of all. It's at 0, 0. And then I haven't really talked about the number in the front here, which is in front of the absolute value. And that number for this problem would be a 1. So this really looks like this: y equals 1, absolute value of x minus 4 plus 2. So you can see this 1 right there. So if we look at it like a slope, 1 over 1, well, I can't really look at it as a slope because this is an absolute value. So if I did, though, I would go up 1, right 1, except that the difference when you do absolute values is you actually have to go in both directions, to the right and to the left. So let's go take a look at what that looks like for the graph. I need to go up 2, right 2, up left, left 2, up 2, okay, or right 1, up 1, right 1, up 1. So pretty much that's what we're going to be doing with this equation also. The only difference is that we take this graph, which is the y equals absolute value of x graph. We're taking this graph, and we have to move that because my vertex is, for this particular g of x, is at 4, 2. So if I move over 4 and up 2, the vertex for that graph is here. So basically what has happened is that this this absolute value, which was the parent function, has moved now, or what we call in math translating, 4 units to the right and up 2 units. And now it has moved. And that's why you see two graphs on this graph. But in reality, we were just trying to graph the g of x. So let me mark them for you. This one here is f of x. That was the parent function. And the new one is g of x. Okay? So this peak one here started off here as f of x, and now we shifted 4 to the right and up 2. So I hope that helps to understand how we can graph using our absolute value functions. Okay, I'm going to help you with B here. Okay, B is on page 592. So find 592 in your textbook so that you can write with me. Okay, we're looking at the graph of g of x. So you can see here that I'm looking at these two numbers. So, and this is the graph of g of x. Now remember, the first one needs to change, so it's going to be positive 1. And the second one is positive 3 because it stays the same. And this is going to become my vertex. So now I'm going to go over to the graph, and I'm going to find where 1, 3 is. So I'm starting at 0. I'm going to move over to 1. Here's 1. And I'm going to go up 3. So 1, 2, 3. And you can see there that that's my vertex. So I'm going to plot that point. So now that I plotted that point, I'm going to look at the number that is here, right between the equal sign and that absolute value. So I'm going to rewrite the equation up above. So you can see that I have g of x is equal to 1, the number 1, absolute value of x minus 1, absolute value, plus 3. So I'm looking at this 1 here. And according to a slope, it would be rise, which is 1. So we're going to go move up 1. But then the run is also a 1. So 1 over 1 is 1. But this time I'm going to move to the right and to the left so that I can create that V shape. So let's go look at what that looks like on the graph. So here I am at my vertex. I'm going to go up 1, but then I'm going to go to the right. And I'm also going to go to the left to create those points. I'm going to show you those points. So from my vertex, I went up 1 and 1 to the right and 1 to the left. I plotted those 2 points, and now I'm able to make my V shape. So one goes this way, and the other connection goes to the left. And that's pretty much how you graph an absolute value. Okay, I'm on page 593 now. I'm looking at A and at B. So let's talk about these numbers now were in the front, the A. The A is equal to -2 for this problem. Okay, so the A is equal to a -2. That's for this problem here. And you could see that I found it from there. Right here between the equal sign and the absolute value. The A for this problem is 1/4. So let me write that down for you. A is equal to 1/4. So you can see that I got that from there. Okay. Now, when our A is a negative number, our absolute value, this is the parent function, which is the original function, which is y equals absolute value of x. You can see the difference of what happened here. The absolute value opened downward. It's opening downward because this A is a negative. Okay, so whenever you see that negative in the front, it's going to reflect your absolute value. Not only did it reflect, but if you notice, it actually got thinner. It got thinner. It used to be open a lot more, and now it's closed up a bit. Okay, if you look at the answer for B, you can see that this is the parent function, y equals f of x equals the absolute value of x just by itself. That's the parent. And you can see that now g of x has gotten wider. So when you have a fraction, your absolute value opens up a lot more. And when you have a whole number bigger than 1, like if you had 5 or 6 or 7 or 10, then the bigger your number gets, the thinner your absolute value will become. Let's take a look at that. Okay, so you can see here that if A had been positive, it would have been this blue absolute value here. But since A is a negative, what happens with the blue is that it opens downward. Now, your absolute value actually is at 0, 0. Okay, so that's what happens to your absolute value. For this one here, it opened up. You can tell it opened up, and that's because when you look at the number at the front, the A, it's 1/4, which would mean that you're going up 1, but then you're going right and left 4. So let's take a look at that on the graph. I went up 1 and then moved over to the right 4. 1, 2, 3, 4. So see, I have a point there. And also to the left 4. So 1, 2, 3, 4. And you can see I have a point right there. So that's why the graph gets wider. Okay, it's time for me to help you out with some homework problems. So why don't we try out number 4? So let's look at number 4. That'll be our first one. Okay, so let's start by finding out what our vertex will be. Okay, so you can see that our vertex, our first, the one that's inside with the X, our H has to change signs. So I change it from a positive to a negative. And then you can see that the K, which is the outer number, does not change signs. So it was a negative and it stays a negative. So let me move this vertex over. Now I need to find out where that is on the graph. So when we look at the graph, we're going to move over to the left. So this is telling me to move left 7 and down 1. So I'm going to start at 0, 0, and we're going to move over left 7. 1, 2, 3, 4, 5, 6, 7, and down 1. I need a dot here. Okay, so I put that dot there, and now we're going to move this point here so that I can label it. That is my vertex. Now I know that my graph is going to open up because I have a 1 here. So my number that I need to look at is 1/1, which is equal to 1. And that means I'm going to go up 1, and I'm going to go right and left 1. So all of this starting at my vertex. So starting at the vertex. So now let's look at what that looks like on the graph. I'm going to go up 1 and right 1. So I need a dot here. Let's put 1 there. And I'm also going to go up 1 from the vertex and left 1. So I need a dot there. So let's put 1 here. Okay, now that I have my 3 dots, that's what I need. I need 3 points. I am able to now make my line. Okay, so you can see that this is only 1/2 of my absolute value. I still need to do the other side of the absolute value. Okay, and there's the other side that's connected. And pretty much that is it for the absolute value. It's that easy, really it is. Okay, I'm going to do number 18 with you next. I need to talk about the vertex first, so I'm going to try and help you rewrite this. So this will rewrite into negative 2.5 and absolute value of x plus nothing plus nothing. So my vertex is going to be 0, 0. Okay, pretty much that's it. So my vertex is here. There's my vertex. Now for my finding out my 3 points, I'm going to use negative 2.5. So that means I'm going to go down 2.5 and then over 1. So I'm going to go right 1 and left 1 from my vertex. So going down 1, 2, and 1/2 is, this is 1. Let me make lines so that you can see it a little bit better. 1, 2, 3. So when you see that, it's a little bit differently. So 1, 2 and 1/2. So here we go, 2.5, and then I need to move over 1 and right 1. So I'm going to need a point here, and I'm going to need a point here. Let me put those points for you. Okay, so now my 3 points are on the graph. I'm going to graph my absolute value in pink, and you can actually see that my graph, I already knew it was going to open downward because my number, my A here is a negative number. So let me graph my line, my absolute values. So here's the first half, and here is the second half. Okay, now it'll probably come out a lot nicer for you since you'll be using a ruler. Okay, the last problem that I'm going to be doing for you is number 20. So you can see here that if I were to rewrite this again, I would end up with negative 2 over 3x plus 0 plus 0. So my vertex is 0, 0. And I'm going to erase the equal sign there because I don't really need that. So since my vertex is 0, 0, here's my point. Now I'm going to use this number here, which is my A, and since it's negative, I know my graph is going to open downward. My V shape is going to open downward. So I have negative 2 over 3, which means I need to go down 2 and right and left 3 for my vertex. So I'm going to go down 1, 2 and right 3, 1, 2, 3. So I'm going to put a point here, and I'm going to go down 2 and left 3. So I'm going to put a point here right before the negative 4 and right before the 4. Okay, so now that I have my dots, I can actually draw my absolute value. So there's my first half, and here is the second half. I kind of didn't draw that the best that I could have, so let me try that again. So there's my second half. So there's my absolute value, and it really is this easy to graph your absolute values. And you can see that in this graph is wider than the parent, and the parent would be y equals absolute value of x. It's also reflected across the x-axis. Okay, and I could tell that this is reflected across the x-axis because my absolute value parent function should be above the x-axis, but since it is a negative, it is reflected across the x-axis downward. So we just call it reflected across the x-axis because the x-axis was the line of symmetry that was used in order to bring your absolute value from the top of the x-axis down to the bottom of the x-axis. Okay, and pretty much that. I hope that helps you to start and to finish your homework. Good luck.